Let's talk about global atmospheric circulation. So it's day 5 of these videos. I'm going a bit mad because it is 11 o'clock at night currently, but I wanted to get this up for you. So what is global atmospheric circulation? The atmosphere, the air above our heads, is a highly complex swirling mass of gases, liquids and solids. These include water droplets, water vapour, ash, carbon dioxide and oxygen, to just name a few. So how does the global atmospheric circulation work? It's a very fancy word for 11 PM. Global atmospheric circulation involves a number of circular air movements called cells. These cells join together to form the overall circulation of the globe's atmosphere. If you were to split the northern and southern hemisphere in half, there are 3 cells on the northern hemisphere and the 3 cells on the southern hemisphere. They mirror image each other, they basically look the same, but yes. So, air that is sinking towards the ground forms an area of high pressure, for example at the North Pole. Winds on the ground move outwards in these areas. Air that is rising forms low pressure on the ground, for example at the equator. Winds on the ground move towards these areas of low pressure. Winds on the ground are distorted by the Earth's rotation. They curve as they move from areas of high pressure to low pressure. This is called the Coriolis effect. I will explain this in slightly more detail in a second. But the surface winds are very important for transferring heat and moisture from one place to another. And the patterns of pressure belts, such as the polar high, and the winds are affected by seasonal changes. The tilt and the rotation of the Earth causes relative changes in the position of the overhead sun. These seasonal changes cause pressure belts and winds to move north during the summer and then south during the winter. So I've just gone and got my A-level notes to explain this a little bit better for you. So I'm going to put this picture on screen here. This is the global atmospheric circulation model. We're just going to focus on the northern hemisphere here because it's exactly the same in the southern hemisphere. So if you look at the equator, 0 degrees. Yes, so at 0 degrees we have the Hadley cell in the northern hemisphere. You'll see on the left and right of the picture the Hadley cell. At the equator, the hot air rises. It's an area of low pressure and hot air rises up. As it rises, it starts to cool because it's cooler higher up. There is a geographical term for that, but you don't need to know that. Yeah, as it rises, it cools and it's got to go somewhere. That we are within the barriers of the atmosphere. So think of it like the skin of an orange. Strange analogy, I know, but think of like the skin of an orange. Everything is happening within that skin. We can't escape the atmosphere. It's what keeps us safe, it's what protects us, it what protects an orange. So as the hot air rises, it reaches the atmosphere. It reaches as far as it can go and it can't go any further, so it moves. It cools and it moves. So this is what the Hadley cell is doing. It moves northwards. In our case, it also moves southwards in the southern hemisphere, but we're talking about the northern hemisphere. So it moves northwards, and then it gets to a point that this cool, dense air can't carry itself any further, and so it starts to sink. This is at about 30 degrees on the Earth, north or south, and so it starts to fall. This is where we get an area of high pressure. As the cool air from the Hadley cell is falling, it's where we see a lot of rainfall. It's where we will see moist air, lots of rainfall, lots of convectional currents. Yeah, cool air is falling in precipitation. And within the Hadley cell, that then sinks, warms because it's still close to the equator, and moves southwards, and that's what we call the Hadley cell. If you move up to what it calls the Ferrel cell, take it as you will, I don't know what's called that, but it falls at the same point of the Hadley cell at 30 degrees. So if you then look at the Ferrel cell, this cool air has fallen, it reaches the Earth's surface, it warms up, it moves northwards, and at these areas it warms and it rises. It comes into contact with the cold air of the polar cell, and therefore it rises. And in the feral cell, it then cools as it comes round, condenses at about 30 degrees and cools again. And then the polar cell, cool, cold air at the polar north, which is what we call the North Pole, and the South Pole. These are areas of high pressure. When moisture is falling, it then moves southwards and round, and when it comes into contact with this warm air of the feral cell, it rises, and those loops, there are 3 cells for each hemisphere, and they kind of loop around the whole Earth. So if you imagine it, if you've got an orange, split it into 6, and you could call the top one the polar cell, feral cell, Hadley cell, and then again halfway around, Hadley cell, feral cell, polar cell. They are exclusive to each other and have the same sort of like rules in each as this picture shows. So I hope that has been helpful. It's not a very extensive description. I will link a video up here that I have done for the A-level geographers that you might find useful if you don't fully understand global atmospheric circulation. I didn't learn it till A-level. You might not need to know it in as much detail as I've just described it, but it does influence our weather, which is what we're going to talk about next. So the global atmospheric circulation is what actually drives the world's weather. The circulation cells, pressure belts and surface winds affect the weather around the world. So the cloudy and the wet weather in the UK. The UK is located at about 55 north, just below the 60 degree north line of latitude. This puts the UK close to the boundary of the cold polar air moving down from the north and the warm subtropical air moving up from the south, from the polar cell and the feral cell. This is about where we are and when they move and rise up. The boundary between these 2 air masses is unstable. Here there is rising air and low pressure belts, which is the subpolar low, on the ground. Rising air cools, condenses and forms clouds and rain. This is why it's often cloudy and wet in the UK. Surface winds in these mid-latitudes come from the southwest. These winds bring warm and wet conditions to the UK, but sometimes the cold polar air moves from the north, moves further down over the UK, bringing cold and snowy winter weather, I should say. A hot and dry desert. Most of the hot deserts are found at about 30 degrees north and south of the equator. Here the air is sinking, making a belt of high pressure, the subtropical high. Air isn't rising here, so there are few clouds falling and little rainfall. The lack of cloud makes it very hot during the day and very cold at night, as heat is lost quickly from the ground. And then at the equator. At the equator, air is rising, and there is another low pressure belt, the equatorial low. This part of the world is much hotter than the UK, with sun directly overhead. Equatorial regions, such as the regions in Africa and Southeast Asia, experience hot, humid conditions. It's often cloudy with high rainfall, and this is the region where tropical rainforests are found. So the question we're going to be looking at today is explain how the global atmospheric system affects the weather and climate of the tropics. Yeah, hot air is rising at the equator, isn't it? There's a lot of rainfall, there's a lot of clouds, very humid conditions, so that is caused by the Hadley cells meeting at the equator. Then at 30 degrees north and south we have the Hadley cell meeting the feral cell, an area of high pressure as the air is falling, but it's very warm and very dry because there is no condensation or moisture in the air because it's all at 60 degrees north and the equator, or 60 degrees south and the equator. And then the UK, you can mention the UK as well. We're about 60 degrees, 55, when the feral cell and the polar cell meet, and we're in this unstable middle ground where the jet stream changes, and that's exactly what it is. The jet stream is the boundary between the polar cell and the feral cell, and this changes, which is why sometimes we have a heat wave because the jet stream has gone further north. Sometimes we have a really cold snap where the jet stream has come south. So I hope that has been somewhat useful. I need to make sure my facts are straight when I actually edit this, but But yeah, I hope it's been useful, and I will see you same time, same place tomorrow at 7 AM. Subscribe below so that you don't miss them, and yeah, I'll see you tomorrow. Bye guys.